This is a note for section 4.6. In 4.5 we graph sine and cosine. Today we're going to look at tangent, cotangent, secant, and cosecant. And we're going to talk about the differences between what we did in 4.5 and what we now have to do in 4.6. So we're going to start first by looking at the basic one, which is tangent. Again, the unit circle sine of x is given by the y-coordinate of the point. Cosine is the x-coordinate on the unit circle. And so if we were wanting to find the tangent, we suggested the easiest way was take the sine of x over the cosine of x. And so we're going to use that idea where we can divide them. And you'll notice in our table we've got a place for sine and cosine, and then we'll actually divide them to find the tangent. You might, by the end of this, be able to do that without showing all three of these, but for the time being, that's at least how we're going to set this up. What I'm going to do is draw the basic unit circle again. With sine and cosine, we said all you needed to know were these four basic points. The problem is, as you start getting into these reciprocal functions and some tangent, which is a little bit more difficult, which is a ratio function or a quotient function, you need more than just the basic axis angles, you know, the 0, 90, 180, 360, things like that. We also need multiples of 45. So I'm going to put in the exact values for the 45. At 45 degrees, the exact value is the square root of 2 over 2 for cosine, the square root of 2 over 2 for sine. When I move it to the second quadrant at 135, my x value is a negative square root of 2 over 2. My y value is a positive square root of 2 over 2. When I move it in the third quadrant at 225, both x and y are negative. And when I move it into the fourth quadrant, then we're looking at the fact that the cosine is positive and the sine is negative. Okay, so we have those points. Again, if you have your unit circle in front of you, you might not have to draw this, but at least want you know where it's coming from. So at 0 radians, we look, the sine is 0, the cosine is 1. If I were to divide 0 by 1, I get 0. And this is a process as we go through. We also need the pi over 4 increment. So at pi over 4, the sine is the square root of 2 over 2. The cosine is the square root of 2 over 2. And when I divide these, you get a value of 1 because they're identical. I look at pi over 2. The sine is 1, the cosine is 0. When you divide 1 by 0, you get something that's undefined. We look at the next multiple of pi over 4. So this is 1 pi over 4, 2 pi over 4. This would be 3 pi over 4. You know what? Let me keep going. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. So it's like we're counting our way around the unit circle again. Okay, let's go back to 3 pi over 4, which is in the second quadrant. My sine value is a positive square root of 2 over 2. My cosine is a negative square root of 2 over 2. When I divide these, you get negative 1 for the tangent. At pi, my sine is 0. My cosine is negative 1. 0 divided by negative 1 is 0. For 5 pi over 4, which is down in the third quadrant, both sine and cosine are negative. When I divide them, then I get 1. At 3 pi over 2, my sine is negative 1, my cosine is 0. When I divide them, I get an undefined fraction. At 7 pi over 4 in the fourth quadrant, my sine is negative, my cosine is positive. When I divide them, I get negative 1. At 2 pi, I get a sine value of 0, a cosine value of 1, which gives me a 0 for my tangent. Now you should start to see a pattern. If you kind of look in the middle, you can see it's undefined, negative 1, 0, 1, undefined. Negative 1, 0, this should be a 1, and then again an undefined. Here, 1, 0, this should be a negative 1, and then again an undefined. These undefined marks are going to be our asymptotes. So I'm going to draw a couple of these. Let's put in our negative, and again, this time we have to go by pi over 4s. So I've got a pi over 4, and then a pi over 2. a 3 pi over 4, and then a pi, 5 pi over 4, and a 3 pi over 2, 7 pi over 4, and then 2 pi. And you'll notice my y values go from 1 to -1, and then we've got some undefined. Okay, now let me change my color a second, and let's draw this in. I'm actually going to start with my undefineds, and I'm going to make these asymptotes. So I have a vertical asymptote at pi over 2, so I'm going to draw in my dotted line there. I also have a vertical asymptote at 3 pi over 2. All right. And then I'm going to start looking at plotting values. At 0, I get 0. At pi over 4, I get a value of 1. And we said if I went negative pi over 4, I should get a value of -1, according to our pattern. At 3 pi over 4, I get -1. At pi, I get 0. And at 5 pi over 4, I get 1. At 7 pi over 4, I get -1. At 2 pi, I get 0. And you're starting to see at least these little curves. And I'm going to start here in the middle because this is then kind of the curve we see. And I could do the same thing and kind of keep it going. And again, we can kind of see that here as well. Okay, if I went and extended this a little bit, at negative pi over 2, I should find another horizontal asymptote. So I'm looking at this. Okay, here's my graph. Now let's talk about period. How often does it repeat? Well, this is one whole period, and then it repeats again for another whole period, and then it repeats again for another whole period. And so in between my asymptotes is where you see a period. Now I want to know how long it is, not where start and finish is. So from pi over 2 to 3 pi over 2, well, if I look at my unit circle, from pi over 2 to 3 pi over 2, that's half the circle, and half the circle is a value of pi. My domain is going to be, as I look at this, all reals except wherever my asymptotes occur. And so I'm going to start with my asymptotes first. My asymptotes are at every multiple of pi over 2 plus the period of pi. So my first asymptote after 0 starts at pi over 2. Then I go a whole distance of pi, and then I get another one. And if I go a whole distance of pi, guess what? I'll get another one. So we say plus pi n. And this means basically for every multiple of pi after pi over 2. So every period from there out. Okay, so I'm going to use that asymptote for my domain. My domain, I can put in any angle except my pi over 2 plus pi n, except for where those asymptotes occur. So my domain for all of these reciprocal and quotient functions will be all reals except wherever the asymptotes are. My domain, you'll see these arrows go down and all the way up. That means from negative infinity to infinity, or all reals, kind of as we're looking at it. And so this is the idea of graphing a tangent. Now cotangent, we're going to do pretty much the same thing. So let's scroll down to cotangent. I'm going to go back to my blue coloring. Again, you can draw the unit circle. I'm going to let you use the one above or your own, okay? And you decide. But again, sine is given by the y, cosine is given by the x. Cotangent is cosine divided by sine. Okay, I'm still going to list everything the same way. I'm going to go again by multiples of pi over 4 in my table. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And I'm going to basically set up the exact same sine and cosines from above, because we already took those from our unit circle. So we said the sine at 0 was 0, the cosine at 0 was 1. I'm going to wait to divide these at the end. At pi over 4, square root of 2 over 2 for both sine and cosine. At pi over 2, you get 1 for sine and 0 for cosine. At 3 pi over 4, the sine value is positive, but the cosine value is negative. pi, you get 0 for sine, negative 1 for cosine. At 5 pi over 4, both sine and cosine are negative. At 3 pi over 2, the y value is 1, the x value is 0. And at 7 pi over 4, the y value is negative, but the x value is positive. And again, 0 and 1 relates back to the 0 radians. Okay? Now the hardest part is you got to divide backwards. Don't forget we're taking cosine over sine. So if I take 1 and divide it by 0, I get an undefined fraction at 0 radians. The square root of 2 over 2 divided by the square root of 2 over 2 is 1. 0 divided by 1 is 0. Negative square root of 2 over 2 divided by positive square root of 2 over 2 is negative 1. And we go again. Negative 1 divided by 0 is an undefined fraction. Negative square root of 2 over 2 divided by negative square root of 2 over 2 is 1. 0 divided by negative 1 is 0. A positive divided by a negative is negative 1. And finally, 1 divided by 0 is an undefined fraction. So you're using basically the same table, you're just dividing them in a different order. So we're going to set up again our graph. And I'm going to go out far enough just to make sure. And I'm going to go to a negative pi over 4, and I'm going to go out to a negative pi over 2. So pi over 4, and I'm going to let you guys fill this in a minute. Go out like this, and again you can see we go from positive 1 to negative 1, and I'm going to again switch my color so that we can look at this. And again, I always start with my asymptotes because I think if you can put those on first, then you know where your graph should be in between. So at 0 radians, I have this undefined vertical asymptote. And again, I always put my asymptotes in different colors. Again, I don't want to touch them. At pi, I have an asymptote, and at 2 pi, I have an asymptote. And you know what, let's even pick a different color, and we can see this pretty clearly. Okay, at pi over 4, I get 1. At pi over 2, I get 0, and at 3 pi over 4, I get negative 1. And you can see kind of how this curves. At 5 pi over 4, I get 1, and then 0, and negative 1. And again, you can see how it curves. So if I kept going at 9 pi over 4, you get 1, and then 0, and if I kept going negative 1, and I could keep putting these in. And so you start to see this idea. Now this should look really familiar to the one above. It just, instead of going up, it's increasing in between its period. It cotangent decreases within the period. Now again, where's my period? If you look, it takes pi to break the asymptote and then repeat itself again. Okay, and so here we've actually shown 3 periods of pi, but again, we're just looking. I want to skip domain and range until I've done my asymptotes. Where are my asymptotes? My asymptotes are at every multiple of pi. And the way we say this is pi n. Because I could have 1 pi when n is 1, or 2 pi when n is 2, or 3 pi when n is 3. You could keep going. Okay, so it's every multiple of pi. My domain then is going to be all reals except the multiples of pi where I have my asymptotes. And again, range, if you look, the arrow increases this way and decreases all the way down, so from negative infinity to infinity. So you can kind of see, again, tangent and cotangent are all based on the same thing. The biggest thing, though, that to keep in mind is you need the pi over 4s to help do the table. Okay, and we may not give you this table setup like we did here. We're going to say, hey, kind of make your own table. And so you need to remember that for only the sines and the cosines do you need the main axis points. Otherwise, you should be putting pi over 4 in for the rest of them. Okay? On the back, I'm going to go through the secant and the cosecant. And the last two examples then I'm going to leave for us to kind of work on in class together. So let's slide this down. Okay. As I look at the first one, cosecant is the reciprocal of the sign. And again, don't forget when you go from a C to an S or an S to a C, you again should not keep the same letters. So it's the reciprocal of the sign. So here's what I'm going to do. I'm going to graph the sine curve first, and then I'm going to show you how that relates to the secant curve. Okay? Let me start. I'm going to leave myself some room because eventually we're going to make a table. But I'm going to just start with what I remember from sine. And again, we kind of expect that the sine curve and the cosine curve at this point in time you should be able to do. Now we've spent a whole day, and I know that's not a lot, but that's something we expect that you're practicing and you're aware of. Okay, so here's what I've got so far. I'm going to spread this out a second, negative pi over 2. Let me go back to the sine curve. The sine curve started at 0, and I'm going to leave this in the same color. At pi over 2, it went to 1. At pi to 0, 3 pi over 2 went to negative 1, and 2 pi went to 0. And negative pi over 2 goes down to negative 1. And so I get this smooth curve. And again, please remember, sine starts at the origin, cosine starts at 1. Okay, now, if I'm doing the reciprocal, let me change my color so that we can kind of stay on the same page. If I'm doing the reciprocal, I can take each point and just do the reciprocal, but I told you cosecant and secant, you need some extra pieces like the pi over 4s. So I'm going to start with my angles, and I'm going to go 0, and then I'm going to put in my pi over 4s, just like we did for tangent and cotangent. So 3 pi over 4 and a pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Okay, now I'm going to go to my unit circle, and if you want to kind of draw another unit circle over here, you can, or you can just look then at the unit circle that you have and stick that right next to you. Here's what I'm going to do. This y value, I'm going to use the reciprocal of the sign. Okay, so the normal sine value at 0 is 0. So 1 divided by 0 is undefined. At pi over 4, and I'm going to write this in not quite the right way, but the sine value is the square root of 2 over 2, so if I do the reciprocal, it's 2 over the square root of 2. And we never leave that, only for table purposes am I doing that. At pi over 2, let's go, that's right here, this is the point 0, 1, so sine is 1. So 1 divided by 1 then is 1. At 3 pi over 4, it's square root of 2 over 2 for sine, so we're going to do the reciprocal 2 over the square root of 2. Again, I hate that, but we're going to go with it. All right, let me try this again. Actually, we're looking at pi, which is the point negative 1, 0. So the sine is 0. 1 divided by 0 is undefined. At 5 pi over 4, you have negative square root of 2 over 2 for sine. So its reciprocal is negative 2 divided by the square root of 2. At 3 pi over 2, we have the point 0, negative 1. So negative 1 is sine, and 1 divided by negative 1 is negative 1. At 7 pi over 4, the sine value is negative. So it's negative 2 divided by the square root of 2 when I take the reciprocal. And at 2 pi, you have the point 1, 0. So 1 divided by 0 is again undefined. Okay, so I'm starting to look at it. There's my table. Let me change to a kind of a brighter color here a second, and let's see if we can take a look at this. At 0 now, I have this undefined line, because I said I always start with my asymptotes. At pi, I have an asymptote, and at 2 pi, I have an asymptote. Okay, so before I even start, let's say our asymptotes or every multiple of pi, so we say pi n. All right, let's graph the rest. I'm going to start at pi over 2 because that's 1. So pi over 2 is the same point. 2 divided by the square root of 2 is bigger. And so this actually comes up like this. And at 3 pi over 2, it's at -1. And this is bigger than negative, or smaller than -1. And so you end up getting a graph that looks like this. And so what you'll see is it's kind of like a bunch of parabolas. Is this cosecant curve, and it only touches the sine curve at those maximum or minimum points. Okay, now, how does it repeat? Let me find a better color. This repeats, it has one up and one down before it'll go back up again. So this whole thing here, as messy as this is getting, is a period, and the period is 2 pi. The period of a normal sine curve is 2 pi, so its reciprocal function should also have the same period. Now what's my domain? All reals except for where my asymptotes are, which is at pi n, every multiple of pi. The range is going to be the hardest part, because the range for this function, the lowest, the highest point here is from -1, and then it goes down to -infinity. So -infinity to -1 including, and from +1 up to infinity for the other branch. Okay, so looking at this, and we're going to do this one more time with the cosecant curve, the secant curve. It's going to be a similar shape or look to the graph. Okay, a little messy, but I'm hoping you kind of got the idea. Let me slide down to the next one. Let's look at the secant curve, and then I'm going to stop with the secant curve. So I'm going to draw kind of a line in here, because I'm going to stop here, and we're going to do these in class. Now, if you're feeling daring after this and you can look at changes and things like that, then great, give it a shot. If not, I'm okay with that. We're going to start with that tomorrow. So secant is the reciprocal of cosine. Okay, so again, I'm going to start with the cosine curve. So here we go. I am going to just trying to see how nicely I can make this. Let's see if we can do that again, hopefully without all of the table mess that we had before. But let's do it -pi over 2. And I'm going to start with my pi over 2's. And then here's my pi over 4's. So this is 7 pi over 4, 5 pi over 4, 3 pi over 4, and pi over 4, as well as a -pi over 4. Now I'm going to put this a little closer together, so hopefully we can see this a bit better. Let's talk about cosine. Cosine starts at 1 and then goes to 0. I'm sorry, 0. At pi, it's -1. At 3 pi over 2, it's 0 again. And at 2 pi, it goes back up to 1. So we get this curve. And it goes back over here. Okay, so you kind of get this curve. Okay, well, let's talk about making this table. Let's see if I can make this table actually over here. We again want to look at the pi over 4's. So I'm going to start with 0, pi over 4, pi over 2, pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4. Am I going to make it? There we go, 2 pi. All right, as we look at this, again, this y value is going to be 1 over the cosine. So if you again draw your unit circle, 1, 0, 0, 1. And again, I think it's easier if you've got your unit circle ready, but keep this in mind. Okay, here we go. I'm looking at the y values this time. So 1 divided by this cosine, 1 divided by 1 is 1. At pi, I'm going to start pi over 2's and then I'm going to work my way around. The 1 divided by 0 at pi over 2 is undefined. At pi, 1 divided by -1 is -1. At 3 pi over 2, 1 divided by 0 is undefined. And at 2 pi, again, 1 divided by 1 is 1. Now, at the other increments of 45, we take the reciprocal. So pi over 4 is positive square root of 2 over 2, so 2 over the square root of 2. In the second quadrant, cosine is negative, so negative 2. Let me do the reciprocal as I'm doing this. Negative 2 over the square root of 2. In the third quadrant, cosine is negative, so negative 2 over the square root of 2. And in the fourth quadrant, cosine is positive, so 2 over the square root of 2. Now I'm going to grab a different color, and let's actually put this together, shall we? At 0, you get 1. And again, 2 over the square root of 2 is actually bigger, so that moves up. I have an asymptote at pi over 2. You know what, I better put my asymptotes in first. At 3 pi over 2, I also have an asymptote. And I look at this and it gets bigger here before I hit my next asymptote at negative pi over 2. At pi, I touch at negative 1, and negative 2 divided by the square root of 2 is bigger, so it goes down. And I'll have my asymptote again down here, so if my curve goes like this, as I look, this is going to turn upward. And you can kind of see again those parabola shapes. So let's talk asymptotes. Let's start period. Period of a cosine is 2 pi, so the period of secant is also 2 pi. The asymptotes occur every multiple of pi over 2 plus a full period of pi. So this is pi over 2 plus pi n, which means my domain is all reals except pi over 2 plus that pi n. Okay, again, this is 1 whole pi. To get here is 1 whole pi. So that's where that pi n comes in. And the range is just like the cosecant. You see that I go from negative 1 down to negative infinity, and from positive 1 up to positive infinity. So from negative infinity to negative 1 including, and from 1 to infinity including the 1 as well. Okay, you'll notice domain and range, at least for both secant and cosecant, are the same. Period for secant and cosecant are the same. It's the domain and the asymptotes that shift slightly, a pi over 2. Now we're going to graph some shifts together in class tomorrow, but this at least gives you the basic idea of how to graph those 4 reciprocal functions or quotient functions. So kind of again, if you can, I would suggest take these 4 again now that you've gone through it once, and see if you can do them without either using your notes, and the only thing we're going to allow you to use on the quiz or the test is the unit circle. So that's the end of the lesson for 4-6. Again, we'll cover the last 2 in class.